Is it true that you named Gemini Gemini? Or is that a rumor?
No, that's true.
What is the future of a junior engineer?
We're actually just going to create more software and have more people doing software engineering in an AI-assisted style.
How should we rethink kind of AI architecture for the billions globally that don't have reliable power?
You can actually run a fairly sophisticated machine learning model even on device these days. Maybe it couldn't do that a year ago, but now it can.
Something's got to keep you up at night regarding what you're building.
These tools make it much easier for people to create things that are false but appear true.
You're working on something new called pathways in very non-technical terms. What does it mean and why does it matter? Today, we're joined by Jeff Dean, Google's chief scientist and head of AI research. Known for his pioneering breakthroughs in deep learning and large-scale computing, Jeff now focuses on advancing Gemini at a global scale. He was raised in Hawaii, spent time in Somalia, has had a multicultural upbringing, and speaks about how his perspective has shaped both his technical vision and his leadership in building the future of AI. Hi, Jeff. Welcome to AI Across Borders.
Thank you for having me.
I'm so delighted you're here in Singapore. But really what I want to start with is all the way back when you were in Somalia. Now, at 13, you skipped 3 months of 8th grade to help your parents at a refugee camp in Somalia. Can you walk us through that experience as a 13-year-old American boy?
I'm an only child, and we moved around quite a lot as a kid. My parents were actually in the Peace Corps in Somalia before I was born, and so they spoke fluent Somali.
Wow.
And they would speak Somali to each other when they didn't want me to understand something growing up. But in 1981, there was a big drought in the Somali region. And so they said, oh, well, we speak Somali, we should go help. So they said, we'll pull you out of the last few months of 8th grade. This will be much more educational anyway. And so we signed up to help coordinate the sort of administration of 4 refugee camps with about 20,000 people each from Médecins Sans Frontières, which is a big French relief agency, to International Rescue Committee, which is the organization my parents sort of signed up with. And so we spent about 3 months in Mogadishu kind of coordinating the logistics of how we would get giant lorry loads of rice from the port over to the refugee camps, which were more on the Ethiopian border and so on. So it was a really interesting experience. We spent about 3 months in the refugee camps kind of affecting the handoff from one organization to the other and sort of just helping kind of get sort of basic processes of nutritional feeding for young infants set up and so on.
Wow. And that kind of experience really shapes one's life. I mean, I grew up in Pakistan. I'm also an only child, by the way.
Okay.
And I worked a lot in villages and in visiting women in jails as well to look at human rights and women's rights. And that has shaped the way I approach AI completely. So what did that experience do to your perspective on technology and society?
Yeah, I mean, I think living so many different places and experiencing, many different cultures, many different kinds of ways of living, urban areas, rural areas, overseas environments, in many places in the US, it just gives you perspective of not every place is the same. One thing I really found was that you can always find something amazing about every place and something that's sort of unique and special. And those are different than other places. So they're kind of incomparable in some sense. But I always just try to find the great aspects of any place I'm visiting or living.
I love that, finding something special in all of them. And then you programmed on what was probably one of the first computers that was ever brought into Somalia. And you were surrounded by a humanitarian crisis at that time. Tell us your first encounter with a computer and what it sparked in you.
Yeah, so the first encounter with a computer, my dad was a public health epidemiologist, but he was always interested in how sort of computing could be used to sort of analyze public health data, make better decisions, help people understand, epidemics and disease trends. And the way you did that, say in the early 1970s, was you went and talked to the mainframe wizard in the basement and asked them to write some code for you. And then, a couple weeks later, they would have done that. So he saw an ad in the back of a computer for a kit computer that you could solder together. This was about a year before the Apple One computer came out. So it was an IMSI 8080. I was 9 at the time, so I was probably not very useful, but I kind of like helped him hold the soldering iron as he's soldering it together. And eventually we kind of built up that computer so it had like a keyboard and a screen, which it didn't have originally. And so then I could start to write simple computer games in BASIC. And there was a book you could buy of like lots of source code listings for BASIC. There was no open source software you downloaded. You like bought a book and you typed it all in, and then you could play the game, which was fun for kids. But also I kind of liked the programming aspect of it, so I would add features to the game and I would change the rules, and that's how I got into programming.
That's a fascinating story. That one of the most eminent research scientists in the world started off writing games on a computer. His dad, who's an epidemiologist, bought in Somalia.
Oh, no, the computer was actually bought in Hawaii when we were living there. Oh, it was
Hawaii. Okay.
Then we bought a different computer that was a TRS-80 color computer that was like compact enough to take to Somalia. So we took that with us in a suitcase.
Really?
Yeah.
Oh, wow.
And then we hooked it up to the hotel TV and used that.
When you think about different cultures, and Jensen Huang has talked about this recently, I don't know if you heard, he gave a talk and then said, if you get together 150 of the brightest minds, or the brightest computer scientists, mathematicians, physicists, you can make the next ChatGPT, Claude, Gemini. You've built so many teams that have had such breakthroughs. What differentiates a team that builds a great product? 150 people who are really smart. Is that all it takes? Or what else does it take to build a transformative product?
One of the things you want to do is work with people who are smart and also know things you don't. I find that bringing together lots of different kinds of expertise is a really good way to sort of be able to do something that none of you could do individually. One of the nice aspects of that is when you're working together, some of other people's expertise rubs off on you, some of your expertise rubs off on them, and then maybe you continue working together, or maybe you part ways. But I also think just getting a bunch of people together is often not sufficient. Like you need to all have a kind of shared vision that you sketch out together of what it is you're trying to achieve. Trying to do something very ambitious is usually a way to really get people excited with who are kind of motivated by hard research challenges, things like that. So I find that's a really great, way of working.
But I also think that that's very true. And just getting people together, they can be very smart, but then politics happens, fractures between relationships. How do you manage that when, you have such people who are very intelligent, very motivated, very ambitious, and opinionated about the best way forward?
Yeah, I mean, opinionated is great. But I think unpleasantly interacting with people because you're opinionated is not great. So you really just want to get people that truly value collaboration, that value the perspectives every other person on the team can bring, and want to work hard to get things done and push things forward. Now, one of the things talking about teams that's really dear to me, and you're a dad of 2 daughters, is diversity in STEM, in teams like the ones that build great products like Gemini and others. How do you kind of reconcile that with the challenge that large companies globally have in having more women in their teams? Yeah, I mean, I think you want lots of different kinds of backgrounds and diverse viewpoints to be coming together into teams, because those kinds of teams actually are the ones that are most effective. They're going to build something that really is more inclusive, that is sort of speaks to more people's needs, that really addresses a broader set of users and ways in which the product can be used. So, I think it's really important to create opportunities for people who may not otherwise have them to study computer science, to understand this is a potential career path for people. And that applies to, women who traditionally, at least in the recent sort of couple of decades, have not been, as well represented in computing, but also people from lower socioeconomic status, all these kinds of things where, you don't want to have a field where it's just those with like huge opportunities already as they're growing up are the ones that enter the field, because you will lose out on all the perspectives of the people who could be in the field and would be awesome at it and could help push the field forward.
And I think, it's even when they have the opportunity, Jeff, they end up in schools that just make it such a deterministic, cold process to learn engineering or math or physics. In my case, it was all like we all knew what the right answer was, as if there's always one answer. Mm-hmm. Whereas as I went abroad and studied, I realized it was much more about creative tinkering also. Mm-hmm. And that is something that is really important, I think, in the kinds of fields in AI. Would you agree?
Yeah, totally. I mean, I think there's lots of different ways of teaching, say, computer science concepts. And you could just like explain an algorithm. But I think it's also much better to motivate things with like real world applications of like, why would you want to do this? And what will this enable you to do? And then say, okay, and here's a technique that we can use that creates an efficient algorithm that makes that possible. And I find that just resonates with students of all backgrounds much better if you can find those examples from their own life that they would care about. And then use that to sort of teach the basic concepts. And
I can tell you there are many, many problems to solve in Asia, Africa, Latin America. So definitely that's a great way. And if you could sit down with AI researchers in Riyadh, in Mumbai, Singapore, all of these places are racing to develop their own AI. Mm-hmm. What is some of the wisdom you could share that mistakes commonly made when you're trying to build kind of the next Gemini, version 3 or a large language module from scratch, multimodal, etc.? What are some of the challenges that they should, anticipate and mistakes they should not make?
Oh, yeah. I mean, I think, whenever you set off on an ambitious project, it's really good to understand what has been done before so that you can learn from it. So there's often like lots and lots of great open source resources. There's great online lectures these days that discuss some of the most important sort of aspects of what you need in order to build some of these systems. So you want to learn from that. And these days there's much more information available than there was about sort of how to do AI research 10 or 15 years ago on the web. But then I also think you want to sort of sketch out how you're going to tackle this problem and what is a good sort of ambitious, say 5-year-ish timeframe goal. But then realize that goal will meander a little bit along the way. But it's good to have that kind of where are we trying to go ultimately in the next, longer term period, in the shorter term period where you're sort of trying to work towards that. And you can often identify, okay, we need these 5 techniques to come together and we know how to do those, but then there's these 2 things we don't necessarily know how to do. So we're going to have to do some experimentation on, should we try technique A or technique B or develop some new technique? And often those are the most fun projects because you have 5 things, aspects of it you know how to do, and then the ones you don't know how to do are the ones you can spend the most time on and experiment with.
I totally agree. I think that's what changed my mind coming from Asia, and then it was only when I met all these physicists and mathematicians who looked at computer science or actually math as such a creative endeavor, almost in a poetic sense, right, as opposed to we have to build something and we've executed it and here it is. It was right, all about the challenge and the tango with the possibilities and the challenge.
Let's create a beautiful proof tango together.
Yes. And they would like talk about Borges in one breath and number theory in the other. And coming from Asia, I was totally hooked. Right. Because I'd never, ever seen anyone. And they were Olympiad winners, right? From Romania and Russia and Estonia. And I think that's really what I think is needed, exactly what you're saying. Like, be open to experimentation and welcome that.
Yeah. And I think also just having, educators or professors, teachers who are really inspirational in the material they're trying to convey is just like something that is super, super good for people growing up. I went to a lot of schools growing up, like
Yeah.
11 schools in 12 years.
Oh my God.
But, you remember the handful of teachers that were just like
Right.
way, their style just worked for you, or they like really took an interest in making sure that every student really learned, and those memories stick out even to adulthood. So
100%. Well, now they're developing a lot of AI in different countries. And one of the reasons everybody's developing it is because they feel that if you have AI trained in France, Europe, America, China, you would kind of have those values in the AI that you're interacting with, kind of what is called digital colonialism. And, how would you tackle that? Thinking about Africa, where you've spent time and you go back and invest and give to that community, how can you tailor it to those values and cultures, problems, challenges? Would you agree that this is something that countries should embark on?
yeah, I mean, I think it's a very real concern of, if you're not careful when building these systems, you can definitely introduce all kinds of biases into how the system is trained. You could train on lots of image data, but your only images of, say, weddings are North American weddings, and you'll miss the diversity of all the kinds of weddings around the world, and your model will not know when it sees other kinds of weddings that's a wedding, as just like a kind of one clear example of all the kinds of biases that can be present in the choices you make in training these systems. So I think it's really important that people who are building these systems really take that into account and try to make the system, understand lots of different kinds of cultures, lots of languages. Multilinguality is a really important focus for us within Gemini and within Google. We want our products to be accessible to people who speak hundreds of different languages all around the world. That's only a fraction of the thousands of languages, but it's much better than having a system that only works in 4 languages or 5 languages. And we really put a lot of emphasis on that. And that's actually one of the things we've been doing in Southeast Asia, is working on improving representation in Southeast Asian languages.
Okay.
Collecting data sets. There's a project called Sealed, I believe, in partnership with the Singapore government.
Oh, Sea Lion.
Sea Lion.
Yes.
Is that what it's called? Sea Lion.
That's it. Yeah.
So,
and you are you've done so much in machine translation, language translation has been a big part of your contribution. And I use Google Translate all the time.
Yeah.
So,
and we're always trying to
that.
add new languages.
Yes.
And we have sort of a certain quality bar we want to meet before we sort of offer it as a officially supported translation language. But I think, it is really important to make information available to people regardless of what language they speak, because there's just so much you're missing out on if the internet is inaccessible to you, because only a tiny fraction of the internet is sort of what is readable in your native language.
That's very true. And I'm so glad. I was going to mention Sea Lion. I'm glad that that's in partnership with your team, because that's a big deal for Singapore to be able to create one for ASEAN and really take into account all the languages and dialects from, including in Singapore with English.
Yeah, that's great.
So let's think a little bit, speaking of different countries. One of the constraints we have at the moment is electricity, power, right? And how should we rethink kind of AI architecture? And I know you're thinking about this for the billions globally that don't have reliable power, that don't have connectivity, could be Taka, Congo. How can we get it to them when the whole world is facing kind of this power constraint when it comes to data centers that hold AI compute?
Yeah, I mean, I think one of the things that's important to realize is there's lots of different form factors for AI models that can be incredibly helpful for people around the world. So you can actually run a fairly sophisticated machine learning model even on device these days. And so our latest Android releases, for example, have quite high quality models for their size that actually run on device, can run, completely disconnected from the internet. And then one of the things we also really focus on is how do we make very high quality models that are also very, very efficient. And so that we can sort of bring down the sort of underlying resource costs, costs if people are paying for API usage, energy costs, carbon emissions, water usage, all these things. So in fact, one of the techniques we use is a technique called distillation,
right,
where you have a really high quality model, but it's maybe kind of large and unwieldy and not very usable for many, many people. You can actually take the knowledge from that large model and use it as a teacher for a smaller model. We call this the teacher model and the student model. And the teacher model can teach the student model in a way that makes the student model almost as high quality, even though it's much, much smaller capacity-wise than the teacher model. And that technique has been used to bring very high quality models that normally would need to run in a data center onto your phone. It's been used to bring very large data center-based models into ones that can run on just a handful of chips in a data center and can be made accessible to hundreds of millions of people that way.
So this would be a game changer. I'm sure it's already a game changer, but especially for young people who can't afford but want to learn, want to have social mobility with them through AI and what assistance it can provide. Are you basically saying that in kind of a phone that you could get in a second, third tier city in Pakistan, you would have almost as good capabilities in AI with this distillation technique?
Yeah, I mean, there's sort of a whole spectrum of sizes, but distillation enables you to sort of bring the capabilities of a model that is a larger size down into something that is much smaller, a factor of maybe 10 smaller. So maybe that absolute highest quality model won't fit on a phone, but it'll fit on a laptop or something that you can run offline. And then maybe that next quality down will fit on even, a very accessible cell phone.
And can you give a few examples of what somebody could do on their phone or on their laptop with this smaller model?
Oh, yeah. So, I mean, often these models are multimodal, so they can do, speech recognition to, understand what someone's saying. They can, one really good example that helps with sort of literacy situations is you can actually use the image input. So you can take a picture of something, like maybe it's a can of things and you're wondering what the ingredients are and you can't necessarily read them because you don't necessarily read that language. It could read that out to you in voice form because it can understand the language that's written on there, even if the person using the phone can't.
Oh, all the power in a tiny device.
Yeah.
Well, thinking about what you have done, and you have done so much, Jeff, that it was hard for me to find like 3 things to focus on, because otherwise we'd be here all day. But I think with your more recent milestones, I would think about the TPU program in particular. And we keep hearing about GPU, CPU, TPU. Could you explain it for a business layperson? Why a TPU? Why this marriage of kind of hardware and software? And why is it so important to this age of AI?
Yeah. Great question. I mean, I think, actually the origin of a TPU is a tensor processing unit, which is a set of hardware devices. We've now done about 7 generations of them at Google. Is sort of a specialized device that makes machine learning computations much more efficient and much more, use much less energy to do the computations. And it really sprung out of a kind of a back of the envelope calculation I did in 2013, where we'd been training these kind of deep neural network based models for speech recognition and for computer vision. And we wanted to bring them to many people because we saw that those models were actually much higher quality than the sort of previous non-deep learning based models for those tasks that we had in some of our products. But those models, even though they were much higher quality, like they would reduce the word error rate by a factor of 2 compared to the previous models we were able to serve, but they were computationally quite expensive. And so I did a little thought experiment. I'm like, okay, well, if these models are really good and people start to use speech recognition a lot more because now it doesn't make as many errors, what if 100 million people started talking to their phone for 3 minutes a day? what would we need? And that time we couldn't actually run the models on device. We'd have to run them in our data centers. And it turned out we would need to double the number of computers Google had just to roll out this one feature with an improved speech recognition system in one of our products. And so I'm like, well, that can't be good. So I started to talk to some hardware people. I said, the computations involved in these machine learning models are actually very restricted compared to what a CPU can run. Like a CPU runs Microsoft Word and Chrome browsers and all kinds of crazy things. But the machine learning computations you want to run are really different compositions of kind of linear algebra operations. So things like matrix multiplies or vector dot products, and different machine learning algorithms are really just rearrangements of the order in which you do those kinds of computations. And it turns out that neural networks are also very tolerant of very low precision. So in the same way that it's really easy for you to multiply 1.3 times 2.4, but it's very hard, much harder for you to multiply 1.3762246 times 3.4, whatever. You can actually build hardware that is specialized to reduce precision linear algebra. And that's what a TPU is. And by doing so, we were actually able to build hardware first discussed in 2015, the TPU V1, that was 15 to 30 times faster than contemporary CPUs or GPUs, and was also 30 to 80 times more energy efficient.
Wow.
And that's just game changing, because now all of a sudden we could roll out speech recognition in many more languages to many more people using the capabilities of this much more efficient hardware.
That's amazing. And I think most people just don't make that connection of software and hardware. And I think that's really interesting about what you achieved. And it's game changing.
Yeah.
Otherwise, I think we'd still be sitting, I don't know, very few people would have access to it. And very little could be added as features, as you were saying.
Yeah.
Every time.
And that's also extended our ability to train higher and higher quality models as well, because we use TPUs for that. And so that's able to make, a larger scale training more feasible.
That's a pretty awesome. And now you're working on something new called Pathways. And tell me about Pathways. Tell me why it would matter to a middle-aged professional in Tokyo or in Paris. They're working in their company, right? It could be cosmetics, it could be manufacturing, but this is pretty game-changing also. And I'd love to kind of understand for our audience, again, in very non-technical terms, what does it mean and why does it matter?
Yeah, so Pathways is really a few different ideas, and it's a project we started even before Gemini. So one was we wanted to make it so that you could have a model that actually could understand and deal with lots of different modalities, because we think it's important to have models that people use, not just understand text or just understand code, but understand, images, audio, speech, video. And one of the ways you can do that is you can create models that have a very large capacity to learn from all kinds of different data, but then have only small portions of that model activated for any given example. So in the same way you have different parts of your brain that are good at different things, you kind of want machine learning models to have that same characteristic. And we'd already done a little bit of work in this where we'd created sparse models where you train different parts of the model to have different kinds of expertise. Right. And then you also learn what expertise those parts have. And so you can learn to then take a particular thing you're trying to do and route it to the right part of the model. Sort of like your brain turns on your Shakespearean poetry thing when you're sitting in English class, but turns it off when you're driving the car down the road.
And so it makes it faster, cheaper.
Yeah, faster,
quicker, right?
cheaper. And then also we wanted to be able to sort of generalize to new kinds of tasks, because ultimately the goal of AI is really how do we make it able to do things that we want to be able to do. And the set of things that the model has seen how to do is only a subset of what you want it to be able to do in the future, right? So you want to be able to have the model generalize to new kinds of things it's never been asked to do before and figure out how to do that.
So it's a couple of different things happening, but it's really looking for the optimal path to find the right answer, right? With wherever the expertise is, finding that path, like the brain, as you said, and then being able to generalize from all these experts when you encounter a new problem.
Yeah. Sort of the same way when you're presented with a new problem, you're like, okay, I need to break this down into 4 or 5 different things. I know how to do these 3. I don't quite know how to do this one. So I'm going to try a few different ways. And I think that kind of thing is happening inside machine learning models in a sort of maybe not quite as explicit way.
But that also means that for somebody in kind of a top cosmetics company in Paris, for example, could use it for many different things, the same model, and it would not incur a lot of cost for their company, and it would actually be much faster, potentially also.
Yeah, potentially. Yeah.
So I think that's the kind of thing where there's all this cool stuff that you're doing, Jeff. Like every day I read about it, I'm like, oh my God, this is so cool. But sometimes people also just want to understand the bottom line for them in this age of AI. And I think this is so helpful because I'm a big believer. I'm kind of very against kind of tech elitism. I believe you should tell people. If you tell them in the way you just did, they understand it. And then it's more fun for them too.
Yeah.
And they can, right?
Yeah, I like actually communicating sort of complex technical topics at just the right level for whatever audience I'm talking to. So I have a set of slides I do for middle school, students about how does AI work. And that's like obviously got different material than something I would give to a set of computer science undergraduates. But I think you can sort of find the right level and get people to grasp the concepts you're trying to convey. Maybe not every last nuance and detail, but I think it's really important for people to understand how does AI work? What can it do? What are its limitations? What are the things you should be careful about in applying AI to different problems in the world? And that's true whether you're a middle schooler or an undergraduate or a sort of a professional already out in the working force.
Hey, Jeff, I think it gives people a lot of dignity when they walk through that office door that somebody took the time to explain it to them. That this thing that is both exciting and disruptive, what can it actually do? And I think that's a step a lot of companies sometimes miss out. And it's so cool that you're teaching middle school kids that as well.
Yeah.
Okay, so speaking of Gemini, which you talked about, what, and I use Gemini every day. What is different? Good to know. What is different about Gemini? What makes it really stand out, in your opinion? And what's on the roadmap that people need to know that's exciting and is going to be even more helpful to them, whether in the home or at play or at the office or in cities like Singapore?
Sure. Yeah. I mean, I think there are a few aspects of Gemini that I think are sort of collectively make it quite useful and unique. One is, we focused on multimodality. So being able to have models that work with whatever kind of data you're working with or inputs, be it like a text document or, a video, and you want to ask some questions about the lecture video you just watched, or some audio data, maybe a recording of this podcast, and you say, please summarize this podcast, because I don't have time to listen to the whole thing, but I want to read a few paragraph summary. It can do that sort of thing. And so by having the ability to take a large input and then sort of use that information in handling the user's request, take these 20 research papers and produce me a summary table of all the results for this benchmark that are present in all the 20 papers. That's something a human could do, but it would take them, 20 minutes of work, and the Gemini model can do it in, 10 seconds. Which is great. Like that's the kind of time saving that I think we want people to be doing in their everyday life with AI, because that's where you can really see it make a difference, is not just that it does things on its own, but that it does things you care about for you that give you more time to do other things that you care about deeply.
And is it true that you named Gemini, or is that a rumor?
No, that's true. So Gemini came about because at Google, we actually had a few different researchers working on these independent efforts, and they weren't necessarily talking to each other very much. And we were also sort of fragmenting the compute resources needed to do the research to develop these systems across these multiple efforts. And I thought it would be just much better for us to all work together on one unified effort that was trying to achieve the goals of kind of the union of what these few efforts were trying to do, and to get everyone working together. And so it was really about bringing twins together to start working on things as a single unified effort.
That is so cool to know the origin of that word and how it came together. Well, speaking of these groups of AI engineers and AI engineers in general, we have this new phenomenon of AI agents that people talk about that can do the work of some of the tasks of these engineers. But before I ask you the question about what tasks they can do, could you explain what is an AI agent for our audience? Why is it different from these AI assistants and former AIs that we've had?
Sure. So, an AI agent is an AI model that you can interact with, but the agent also has the ability to go out and take actions in the world or in a virtual computing environment or something like that. So there's lots of different kinds of agents. You could have an agent that learns to play a video game. An agent could also be something that is operating a web browser. You could navigate to a different page. You could type in a URL. You could click on a link. And one of the hopes is, how do we make agents that can take high-level descriptions of something that you want accomplished as a person, and then to go off and figure out the right set of actions in order to accomplish that. So you could say something like, can you reach out to my friends, Fred and Jane, and see if they want to go on a hike? And if so, prepare a list of potential hike spots that work for everyone, and figure out a day that we can go hiking, right? And so there's obviously a bunch of underspecified things, but the hope would be an agent can figure out that it should email or text message the two people you mentioned, ask them when they want to go hiking, get responses. So that's what an agent can do. Now, there's it's a lot easier to train an agent in cases where you have very clear markers of success or failure of what it's trying to do. So in a video game, you often have like the score of the video game, and you're trying to get better and better at getting a higher score. In the web example, though, there's often not very clear definitions of success or failure. But the overall effort in agents, which is a big area of AI research right now, is how do we make these systems or agents that can actually accomplish fairly open-ended tasks in kind of messy environments like the web, or in some cases in physical settings like robots can actually perform operations in a physical environment and then do so successfully. Make sure that they're doing things that are appropriate on your behalf. I don't want it to go out and purchase a $10,000 item.
That's right.
I might be fine with it purchasing a 10-cent item if it seems like that's in pursuit of the goal I've given the agent.
But so a lot of people are wondering, they have large teams. You have a team. Let's go down to you have a lot of research scientists, computer scientists, engineers. Everybody's wondering, what does that mean for junior engineers? Mm-hmm. Kind of, what is your hypothesis on what is the future of a junior engineer? What are the skills they need to learn if some of the tasks that they do will be taken up by these AI agents? Is that even true?
Yeah, I think we are seeing more and more use of AI agents and sort of coding assistive models in software engineering, for sure. Like, we're seeing that internally at Google. More and more of our software engineers are using agents to help them do some aspects of their job. I think the worry is, we won't need as many software engineers, but I think we're actually just going to create more software and have more people doing software engineering in an AI-assisted style and creating more software for the world that is generally a good thing. And so that's kind of the way I would view it. Some colleagues and I actually put together a fairly comprehensive paper looking at a bunch of different sectors of where AI might impact different situations in healthcare and education. And one of the ones we looked at was employment.
Okay.
And we spoke with a bunch of experts in many different sort of fields, including economists and labor specialists. And one of the things they observed was that as past technological shifts have happened, that in situations where demand is inelastic. So in the US, for example, there was a period of time where many people were engaged in agricultural and farming related work because it was necessary to grow enough food for people in the country. But then as farms became more automated, less people needed to do that because we now suddenly could produce the right amount of fruit and vegetables and so on with fewer people. And so then people migrated to cities and went off and did other things. And so agricultural employment went from like 90% of the economy to 3% or something. And I think but in areas where sort of demand is elastic, there, you have much more demand for software if you can make it easier to create software. That's actually kind of an odd thing about some kinds of industries. Airline pilots also turn out to be a thing. As you make planes fly faster and able to carry more people, you actually have more demand for airline pilots, not less.
Yeah, Jeff, coming from Asia, I would say we have, as I pointed out earlier, there's so many problems that developing countries and frontier markets have that we have a lot of work to do. Mm-hmm. And that should keep everybody very busy. And more importantly, it should give people the time to realign their roles. Mm-hmm. But I agree with you that in some cases, the demand is not being met at all right now.
Yeah. One way of thinking about AI models is it really makes expertise much more accessible, right? Mm-hmm. Like, so these models can be good at lots of different things. They can have a lot of knowledge about different subjects. And that can really help people all over the world able to do more things than they would otherwise, because now you have this incredible tool assisting you and knows lots of things.
I think people are maybe not using it correctly. They're not interacting enough with it or role playing enough where it's kind of challenging you back. Mm-hmm. And I think that as education becomes better at explaining how to use AI assistants and agents optimally, people would extract a lot more value out of it.
Yeah, I mean, I think it's also one of the aspects that's probably hampering that a little bit is the capabilities of these models are changing very fast. And so people, maybe played with something a year ago and said, oh, I wanted it to do this, and it really couldn't quite do that. But, often what happens is maybe it couldn't do that a year ago, but now it can. And so I think you need to kind of continually, reset your expectations of what these models are capable of in collaboration with you.
No, it's very true, which is why in Singapore, there's a lot of emphasis on upskilling, no matter what your age. Because I hate the ageism sometimes around this whole thing. At my age, I don't like ageism.
Right. Or the idea that like learning stops when you finish school.
I know.
That's crazy, right? Like
totally
you're learning new things continuously throughout your life, and you should continue doing that. And AI can actually be an amazing tool for helping with that.
Yeah, no, I totally agree with you. So let's now go on to my last couple of questions. One is AI Agent 2040. Okay. What do you think they can do, and what would they struggle with?
2040. I mean, that's a long time. I try not to predict out that far generally.
Pick that's
fine. We can try.
It's not that far. 15 years, I guess, in your field.
Yeah,
that's a long way off.
I mean, I like to think in like 5-year horizons. Yeah. I mean, I think you're going to see a lot more capable AI systems, obviously. One of the really potentially impactful things would be, can AI-assisted science in many different fields make, say, 100 years of progress in 10 or 15 years? Because I think that would be amazing. Like, if you think of the scientific discoveries of the last 100 years, if AI could help us get the equivalent of those and across many different fields in 15 years, that the world would be a completely different place, because 100 years ago, we didn't have computers, we barely had cars, we, didn't have solar panels, we didn't have all kinds of things. And that, I think, is the society we should aspire to, is how can we maximize scientific discovery and innovation for the benefit of everyone?
I love that. But Jeff, this is, you're chief scientist of one of the largest and most impressive companies in the world. And you are an incredible person, researcher, dad, teacher. And you're working on AI, but something's got to keep you up at night regarding what you're building. And what is that? And how are you making sure in your teams and your work that you're preventing that fear or risk that you have?
Yeah, I mean, I think there are definitely some areas of concern for AI. One I am especially worried about is misinformation, right? And these tools make it much easier for people to create things that are false but appear true. So I think that's one area where we need a collection of technical solutions to some of these things, but also maybe some regulatory or other kinds of aspects of societal sort of norms that can help with this area. Another one is sort of shifting in roles of people in society, right? I think if, say, we have, AI systems that can really help do a lot of what some people do in their day-to-day life, how will we make sure that they can refocus and do other things that are super important to society? And I think this is a society-wide problem that governments and others should be thinking about, as well as large tech companies, small tech companies. But this is actually one of the things that the paper I mentioned that I wrote with some collaborators called Shaping AI.
Okay.
So shapingai.com. It's the only paper I have with its own website. That actually touches on some of these issues, like how do we maximize the upsides of AI in society in many of these areas, like where it can be hugely beneficial, healthcare, education, things like that, and then minimize its downsides in some of the areas where it does have some concerns, like misinformation or other areas. So I think that's a combination of technical solutions and other kinds of societal solutions are going to be needed in many of these things. I
will definitely share that in the interview, shapingai.com.
Yeah. It's 30 pages long. We have a shorter version coming.
Jeff, this podcast is kind of my love letter to humanity in an age of machines. What is your love letter to humanity in the sense of how would you say humans should live in this age of machines? If you could share your thoughts, that'd be great.
That's a great question. I mean, I think one of the things I've always been really excited about computing in particular is the ability of a small set of people to create and shape software that can be then used by many, many people. And I think that's kind of a somewhat unique aspect of computing as a profession, is you can touch so many people. And I think we have the ability to create amazing things that are used by millions or billions of people and that really impact their lives in positive ways. And so I think, there are definitely aspects of some kinds of computing or systems that are not all positive, but I think aspirationally, we should be trying to build things that really help people get things done. Things like how can they find information? Things like how can they, engage their creative side in tools that work with them to sort of get the amazing visual images they have out into the world, even if they're maybe not a highly skilled artist. And I think these kinds of things can be really, positive and beneficial for people. And that's what I try to do in my everyday work.
I love that. I love the notion of a small group of people making a difference. And I guess my last question is, speaking of having the capability to make a difference, do you think that anybody anywhere in the world now with access to tools like AI and the right infrastructure and connectivity could be part of such a team?
Yeah, absolutely. I mean, I think one of the things about living in many different places growing up is you see that there are so many talented and motivated people all over the world that, in some cases don't have the opportunities that others do, but have the motivation and the drive and the ability. And so you want to really enable them to fulfill all that potential with access to tools like, amazing AI models that can help them create new things in the world and to fulfill their vision.
Well, thank you so much for this chat. I think it's going to give people a lot of confidence because you made it accessible. You were super generous with explaining things. So this was a great conversation, Jeff. Thank you so much for your time.
Thank you very much. It was a delight.